Video assignment E8, Areas Revisited. Learning outcomes for this lesson. Following the completion of the workbook assignment and the in-class activities, the successful student will be able to 14. Use definite integrals to determine total area and net area, A, between a curve y equals f of x and the x-axis, and B, between two curves y equals f of x and y equals g of x, where both functions are given as functions of x. Advice for mastering the learning outcomes. When we found the total area between a curve and the x-axis in E3, E4, and E5, I said only, but I think totally, to be completely accurate, I think I should have said mostly here. We mostly dealt with functions f satisfying f greater than or equal to 0. In that situation, the total area between the curve y equals f of x and the x-axis on AB is the definite integral from a to b of f of x dx. More generally, to find the total area between two curves on an interval AB, use the definite integral from a to b of top of x minus bottom of x dx, where top is the function on top, meaning it has the larger y values for the same x values, and bottom is the bottom or lower function, meaning it has the smaller y values. And so the way that this works, so let's do an example. Well, let's sketch out an example anyway. Just think about having an interval AB. So here's my A, here's my B. So let's say that one of our functions, f, let's just make its graph. Do this. And then g, say g is the function whose graph does this. And so now what we're focusing on is trying to figure out how to find the area between the two curves. And so if we look at the definite integral of f, it's this blue shaded portion. And if we look at the definite integral of g, it's this black shaded portion. And so what we can do is we can find the area that's between the two curves by taking the blue area and subtracting away the black area. So the area between f and g is the definite integral on a to b of f of x dx minus the definite integral from a to b of g of x dx. When you subtract those areas, you get the area between the two curves, which is right here. And another way to write that area between the two curves is the definite integral from a to b of f of x minus g of x dx. When f and g have points of intersection on an interval AB, they will often trade off as top and bottom functions. To find the total area between f and g, 1. Find the points of intersection of f and g within the interval AB. 2. Use the points of intersection x1, x2, x3, etc. in increasing order to break up your interval into chunks. A to x1, from x1 to x2, from x2 to x3, and so on. Step 3 is test values to determine the top function on each chunk. The top function will have the larger y value when you plug the same value of x into both functions. Step 4 is do a separate definite integral for each chunk. Integrate top of x minus bottom of x on each chunk. And step 5 is add up the values of the individual integrals to get the total area. Total area between the curve and the x-axis. When you find the total area between the curve y equals f of x and the x-axis over AB, you are finding the total area between the curves y equals f of x and y equals 0. As in the general procedure above, you can break the interval into chunks based on points of intersection of y equals f of x and y equals 0. These points are the x-intercepts of the graph of f. Next, determine which function is the top function on each chunk. After that, set up the integrals. When f is above the x-axis, it is the top function. So integrate f of x minus 0, which is the same thing as f of x, on each chunk where f is the top function. When f is below the x-axis, it is the bottom function. Integrate 0 minus f of x, which is the same thing as negative f of x, on each chunk where f is the bottom function. Next, work out the integrals and add the answers together to get the total area. So I will make a note, when we talked about problems like this before, what we did is we just integrated f on each chunk, and then we disregarded negatives as needed. But now that we have this more formal procedure of top function minus bottom function, we can also describe the process in this way. So the way that we did it before was integrate f on each chunk, disregarding negatives. And by disregarding negatives, I mean take the absolute value of your answer on each chunk before adding them all together. If you get a negative answer for an area of a chunk, stop and reevaluate your setup. Area should always be non-negative. However, net area can be negative. But if you get a negative answer for an area of a chunk, it may be because your functions are switched.